So welcome everybody. Thank you so much for joining. This was going to be a workshop at the ISEE 2020 conference, but when that went virtual, all excuse me, all workshops were transferred to webinars during the year. So our webinar today is on the Early Adopters Program for the NASA MAIA for speciated particulate matter data sets for epidemiologists, exposure scientists, and air quality managers and others. I would like to introduce Abby Naston, the Deputy Program Applications Lead for NASA's MAIA, working to maximize the project's societal benefits. She's an applied science system engineer at the Jet Propulsion Lab in California, specializing in applications development, science communications, and stakeholder engagement. So without further ado, Abby.
Thank you so much. And thank you to all of the team at the ISEE conference for your excellent help in putting together this event. So yeah, I'm Abby Naston. I'm from JPL, and I head up the MAIA applications program, and especially its early adopters program, which we hope that all of you who are not already members may consider joining at the conclusion of this webinar. So a couple of ground rules for the webinar today. So we want this workshop to be as interesting and useful to you as possible. We're going to have several people speak today, and then at the end, we'll have a big block of time for questions. So if you could make sure that you are on mute, of course, and we will ask that everyone who's not a presenter, please keep your video off. That's just to maintain the bandwidth for people who might have more spotty Wi-Fi. And as we go along, if you have a question, please type your question in the chat and indicate which of the speakers your question is for. We may have some time as we go along to answer questions, or the presenter may be able to answer your question in the chat. Otherwise, we'll get to your question at the end of the presenters today. Okay, so with that, I'm going to introduce John Haynes. So John Haynes is the program manager for health and air quality at NASA headquarters. And he's also the co-chair of the Group on Earth Observations Health Community of Practice. And he is the sponsor of the MAIA Applications Program, and he's going to give a few words of welcome. Thank you, John.
Well, thank you so much, Abby, and thanks for setting up this wonderful webinar, and thanks so much to ISEE for being our host and sponsor for this webinar. As Abby said, I'm John Haynes. I do serve as Program Manager of Health and Air Quality Applications at NASA headquarters in Washington, but I'm also proud to serve as the Program Applications Lead for the MAIA missions at headquarters. But I will say the yeoman's share of the work is done by my Deputy Program Applications Lead, Abby Naston of JPL. So again, many thanks to her. In the NASA Applied Sciences program, our mission is to discover and demonstrate innovative and practical uses of Earth observations in organizations' policy, business, and management decisions. And we do this across all levels and sectors, including working with local and state governments, regional consortiums, certainly federal agencies, and even international partners, including also the private sector. And the MAIA mission is going to be critical in meeting the objectives of the Applied Sciences mission. You know, when the MAIA mission was chosen, it's important to note that it is the first Earth science satellite mission ever chosen purely for an applications purpose. And that purpose was to look at the societal benefits of health and air quality. So that also shows that the importance of this topic to NASA leadership and, of course, the Earth science community writ large. MAIA represents, again, the first time that our agency at NASA has ever partnered with epidemiologists and health organizations to use space-based data to study human health and improve lives. And MAIA will assess linkages between different airborne particulate matter types and adverse birth outcomes, cardiovascular and respiratory disease, and premature deaths in megacities across the globe. As I thought, in a very catchy way, it was put recently in a NASA web feature published by JPL. They said that MAIA will be getting to the heart of the particulate matter. So I thought that was pretty catchy. And, you know, with this being an early adopters webinar, your charge, you are the early adopters. You are truly the pioneers in utilizing what's going to be an extraordinary data set in order to benefit society and in order to improve our understanding of how the environment impacts human health across the globe. So again, I wish I could stay for the entire webinar. Unfortunately, there's a conflicting meeting this morning at NASA headquarters, but here's to a very successful webinar, and I look forward to hearing any outcomes, results, questions that come from you. Relayed to me through Abby. And so again, thank you so much. Thank you, Abby. Thank you, ISEE, and thanks to our early adopters for being here.
Thank you so much, John. And yeah, as John mentioned, he's not going to be able to stay for the entire meeting. So does anyone have a quick question for John? Okay, I don't hear anything. So with that, thank you very much, John. At this point, we're also going to be able to introduce for a brief period MAIA's principal investigator, Dave Diner from JPL. Dave also is kind of going back and forth between two meetings at the moment, but he wanted to join and say a few words about the current progress of the MAIA instrument and some other details. So take it away, Dave.
Okay, thanks very much, Abby. Thanks also, John, for the introduction. Thanks also to ISEE and all of you for participating. Just to give you an update on what's going on with the project, the major activities taking place now are fabrication of the satellite instrument, deployment of surface monitors that will be put out in the field in our target areas to work in conjunction with the satellite instrument, and development of the ground data processing software that'll take the data from the surface monitors and the satellite instrument to produce particulate matter exposure maps for different types of PM. And then also being put in place are health records, preparations for that in order to perform epidemiological studies, hopefully which many of you will participate in. COVID lockdown has impacted our activities and kind of for several months brought all of those things kind of to a slowdown. We couldn't go into JPL and work on the instrument, but fortunately that has progressing now and we're making good progress. And what's exciting is that the camera, which is the heart of the instrument, which will be collecting the imagery from which we'll retrieve aerosol properties, is built and it's currently started detailed calibration. So that's a major advance in the progress of the project. We're also starting to get the deployments in place of the surface monitors and making the agreements with our international partners around the world for that to happen. So that's where the project is now. And what I think, just to close, I think some recent events have kind of raised public awareness about aerosols. So the intense wildfires in the Western US, COVID, I think aerosols have become more part of the public language. And so I think these things will bring to the fore the importance of studying particulate matter and its impact on human health. And so I'd like to welcome all of you and thank you for participation and look forward to working with many of you in the future. Thank you.
Thanks so much, Dave. Okay, so at this point, we're going to move into, we're going to give a presentation with a little bit of background about MAIA. So I will share my screen. Okay, can someone please confirm that you can see my slideshow?
Yep, you can see it.
Perfect, thank you very much. Okay, so over the next 50 or so minutes, we're going to cover several topics. First, we'll have some background on the MAIA project, which is what this presentation is. We'll hear from two of our MAIA epidemiologists on their plans for MAIA data from Sagnik Day and Meredith Franklin. And we are, since this is a webinar sponsored by the International Society for Environmental Epidemiology, we are focusing on epidemiological applications of MAIA data today. However, we know that some of you on the call may be interested from other user communities, and please rest assured that we do happily support early adopters from all user communities, and our other early adopters events cover those other use cases. And then finally, we'll find out some details about how MAIA data will work, which will hopefully encourage you to join the MAIA Early Adopters program so that you can hear more about the MAIA data. So a quick who's who, you already met me, Abby, and John Haynes, the program manager from NASA Applied Sciences. Next up, we'll have Jeff Walter from the Atmospheric Science Data Center, which is one of NASA's data centers and the center that will be distributing MAIA data. And then we'll hear from two epidemiologists, Sagnik Day and Meredith Franklin. Okay, so first, a little bit about why MAIA is a project. Okay, you may already be familiar with this fact, but if you are not, the World Health Organization says that over 90% of the world's population lives in areas that do not meet WHO's own air quality guidelines. So we know that the problem of being exposed to air pollution is widespread, and we also know that it disproportionately impacts those countries that have fewer resources in order to address the problem. How serious is exposure to particulate matter? The global burden of disease says that breathing particulate matter air pollution is the top environmental risk factor for human health worldwide. I'm showing here the figures from the 2016 global burden of disease. In that year, they estimated that over 4 million premature deaths occurred due to exposure to particulate matter, and that number has only risen since then, unfortunately. However, if we want to address the issue, the very serious health issue of particulate matter exposure, one thing that we still don't understand is which chemical constituents of particulate matter are the most harmful to human health and to the environment. For example, we know that vehicles mostly emit black carbon and organic carbon, but is black carbon, let's say, more dangerous to people than nitrates that come from agricultural activities? So this is a key question that still needs to be addressed so that governments and stakeholders can make cost-effective decisions that will have the greatest positive impact on human health worldwide. So this is the issue that the MAIA project was selected to address. It was selected by NASA in 2016. Our launch is planned for 2022, and we have a baseline mission length of 3 years with a possibility for extension. So I've put MAIA science objectives on this slide, and they are to study the effects of various chemical constituents and mixtures of PM on various health outcomes, ranging from acute illness to adverse birth outcomes to chronic disease. So this is our current target list, and I apologize for the slightly grainy picture. This PowerPoint presentation has an evil setting somewhere that is downgrading my pictures whenever I save. But MAIA has 3 major types of target areas. The blue targets on this map are our primary target areas. And the main thing that distinguishes those from our other targets is that one, we will be revisiting them at a slightly higher frequency. We're aiming for between 3 and 4 times per week. And 2, there is an epidemiologist on the MAIA team who has committed to performing at least 1 health study in each of our primary target areas. You can see that the green targets on this map, the secondary target areas, are more numerous than our primary target areas. These are areas where early adopters or other interested users have reached out to us and said, you know, it would be very helpful to have air quality data in this particular area. We may not be able to produce all of the MAIA data products in each of these secondary target areas, and we will also probably not be revisiting them at quite as high a frequency as the primary target areas, but our goal is to make this data useful to early adopters and to others. And then the final target type is just calibration validation target areas, and these are simply areas that we target routinely to maintain the operation of the instrument. So I'll attempt to explain the MAIA investigation concept in 1 slide. Obviously, this isn't going to get very much into the details. If you have specific questions, I will be very happy to answer them. Just put them in the chat. So we have the MAIA satellite instrument, of course, and it will collect data on radiance and polarization. And then that will be combined with data from a variety of surface PM monitor types, and as well with chemical transport modeling. And the 3 data sources will be combined using geostatistical regression modeling in order to create MAIA's PM maps of PM concentrations. And those will be available, as Jeff will discuss shortly, from the Atmospheric Science Data Center. Then epidemiologists on the MAIA science team, as well as other epidemiologists, including our early adopters, will use health data in order to conduct studies linking concentrations of particulate matter, including, for example, black carbon, organic carbon, et cetera, particulate matter to specific health outcomes. And NASA always asks the team to declare that those health records are not in any way held by NASA. So this is a list of the current MAIA science team. And as you can see, it is quite a varied science team in terms of expertise. You've already met Dave, and there's a wide variety of people that are working on the instrument and the characterization, as well as remote sensing and modeling. But we also have a large group of epidemiologists, as well as expertise from a variety of air quality and public health organizations. So this is the current chart of the planned health studies from the MAIA science team in our primary target areas. So you can see that many of the target areas have more than one health study planned, and also that we've attempted to get a good distribution between acute, subchronic, and chronic effects. Okay, so that was a very quick introduction to the MAIA project. And I'd like to spend the next few minutes talking about the applications program and the early adopters program, because I hope that you will consider joining the early adopters program. Okay, so when I speak about the MAIA applications program, what exactly do I mean by the word application? Because of course it has several definitions. So in NASA speak, an application is when NASA data are used by people outside of NASA to solve real world problems. So NASA has an applied sciences program. You met John Haynes, who's a program manager for the health and air quality sector of applied sciences. But as you can see here, there are also several other sectors. And if you're interested in finding out more about the NASA Applied Sciences program, I've included the link to their website on this slide. So the MAIA applications program is sponsored by the NASA Applied Sciences program. And as the Deputy Program Applications Lead, my role is to collaborate with both the MAIA project and with you, the potential end users of MAIA data. So it's my job to understand what your needs are when it comes to MAIA data, and then to partner with the project to make sure that we are meeting your needs and to the greatest extent possible. So the applications program has several segments, but the one that's most relevant and the one that is indeed the largest is the early adopters program. So what are our objectives in running this program? Well, first of all, we hope that by working with a large number of end users, we will be better able to meet our primary science objective of understanding the health impacts of various types of PM. But on top of that, our kind of pie in the sky goal with the applications program is to move beyond just studying which PM types are most dangerous to human health, and be able to provide information to decision makers and governments that they can use to make decisions that will positively impact human health worldwide. So who is an early adopter? Well, if you're listening to this webinar, we hope that you will be an early adopter. But in general, an early adopter is anyone who is interested in using MAIA data once it becomes available. And we hope that through participation in the program and coming to webinars like this and workshops, you will eventually have a good understanding of how exactly MAIA data can help you in your future work. And what are the benefits of joining the early adopter program? Well, it gives you a chance to offer feedback pre-launch on our data products, because in the course of early adopters workshops, you will get access to test data products that you can use to play around with, tell us what works, what doesn't, and also to prepare to entrain those data products into your work once MAIA has launched. And of course, it gives you the opportunity to collaborate with both the MAIA science team and other early adopters, as well as to receive any assistance that you might need to entrain the data products into your future work. So this is kind of just a little diagram of how the early adopters program works. You know, we're in the pre-launch phase right now, since we're still 2 years away from launch. And we're in this kind of iterative situation where we hold workshops, we share test data products with you, the early adopters provide feedback, and then we go and make improvements to the data products based on that feedback. Post-launch, the program will become more of a capacity building effort, where short courses, user guides, etc., will be provided to help you use MAIA data. So this is my last slide for this particular presentation. And I just, if you're interested in becoming an early adopter, it's quite easy. You can either visit this website and download the contact form to send to me, or if you don't have time to jot down this URL, please just send me an email. I'll put my email address will be available on the slide a bit later on, and I can send you the contact form. And of course, there's much more information on the MAIA project available on the MAIA website. But if you have specific questions, please do put them in the chat. Okay, so that's it for our presentation for background on MAIA. Let me check the time. It's 9:22, so I'm going to go ahead and turn things over directly to Jeff Walter for the next presentation on MAIA data distribution. Jeff is the Deputy Head and Data Systems Architecture and Engineering Lead at the Atmospheric Science Data Center, which, as I mentioned previously, is one of the data centers that distributes NASA data and the specific center that is in charge of MAIA data. So take it away, Jeff.
Okay, thanks, Abby. Let me see if I can share my screen here. I hope everybody doesn't mind. Speaking of spotty Wi-Fi connections, mine has been a little spotty today, so I am going to leave the video off. Go back to record. Okay. Let's see here. Bear with me 1 second. See if that does it. All right. Am I showing anything?
Not yet.
Not
Yeah,
yet. Okay.
Jeff.
Sorry, guys. Let me try.
Give it a
this again.
second. Give it a second.
Oh, okay. I'll do the screen then. Anything?
Nope, not yet.
Gosh. Okay. Well, I anticipated this. Let's see. All right. One more time. One more shot here. And if it doesn't, I'll have Abby do present. Nothing?
No.
Okay. Well, okay. Sorry about that, folks. We don't use Zoom much on my end, so I'm probably just doing something wrong. So, Abby, if you wouldn't mind bringing it up, that would be great. Thank
Okay,
you.
here we go.
Sorry for the delay.
Tell me next when you want to go to the next slide.
Okay, so like Abby said, I'm Jeff Walter. I'm the Deputy Head and Systems Architecture and Engineering Lead at ASDC, and I did leave a couple names off of this title slide, so I apologize. Two of our folks, Abby put them on her intro slide, Makan Verdi and Danielle Grunin, who are two of our science outreach folks and science experts that we have at ASDC that are also heavily involved in MAIA support. So I'm just going to be giving kind of a broad overview of the ASDC and what we do, what we're about, where we fit into the world, and what kind of services we provide that will be applicable to MAIA and to MAIA users. So, okay, go ahead, next slide, Abby, please. Okay, so again, that was, I think, just what I said, give a quick overview, some of our distribution tools and services, and then a little bit about our science outreach and support efforts. So next, please. Okay, so so the ASDC, Atmospheric Science Data Center, is what's known, at NASA as a distributed active archives center. So, and we are part of the broader NASA Earth Science Data System enterprise. So the system itself is called the Earth Observation System Data and Information System, or EOS-DIS. And so if you've ever used NASA data, you may be familiar with this term. And again, it has a lot of different elements or different categories of things. For this group here, if you're a data user, the one that you're primarily concerned about, or your point of access for data will be one of the distributed active archive centers. So over there on the left, and again, forgive the graphic, there's no distinction for the purposes of this discussion between the pinks and the blues. It's all data centers. We're one of 12 science theme based data centers. So, and you can see they're all over the country. Some are at NASA centers, some are at universities, a few are actually at other government agencies. And we are located at NASA Langley Research Center in Virginia. So we're the one in the lower right there in the pink. So next, please, Abby. All right, and so for the ASDC itself, our vision, what we strive to do is to be kind of the leading provider of atmospheric science data products and services to the science community, and we're constantly looking for ways to to kind of to innovate. We have an excellent technical and scientific staff on site at ASDC, and we're always sort of looking for ways to improve. Looking for sources of feedback on what people need, what we can be doing better. So anytime you have, there are various vehicles I'll talk a little bit about later for folks to provide feedback and let us know how you're getting along and or other things you'd like to see. So next, please. So this is us at a glance. Again, our primary functions are there in the lower left. We ingest data from a data provider, which is usually a particular mission, and when we archive that data, it's sort of a full preservation and provenance. It's all it's archived. We have rich sets of metadata. It's backed up. It's off-site. All these other things, and we also provide for the science user the distribution functions, and some of it's just straight download, but we have a variety of different tools and services that people can use to help them in their with their projects. And you can see in the lower or in the upper left there, those are sort of our four primary science focus areas for the missions we support. So it's radiation budget, clouds, aerosols, and tropospheric composition. And we have a wide range of different missions and projects that we support, some of which are still flying, some of which missions have ended, but we still have their data and their data is still available. And the ones listed there are some of our highlighted ones. We support MAIA and MOPIT, MAIA and Tempo, both coming up that we're very excited about, and Ceres and Calypso, of course. And then a variety of different airborne field campaigns, again, mostly focused on atmospheric composition and aerosols. We distribute quite a bit of data. So in 2019, we distributed almost over 2 petabytes of data to 160,000 users in 158 different countries. So it's a lot of data going out the door. Our archive is about close to 6 petabytes, with about almost 4.5 petabytes of that online, directly on disk, so it doesn't have to be pulled off of a tape or anything. So access from the read point of view is pretty rapid. And we're working with our program management at the moment. There's an effort to move some data into a commercial cloud environment, and this at the moment it's focused on AWS. So they are moving full speed ahead with providing data and services in the cloud. So you can take advantage of anybody that wants to do large scale analysis or things of that nature could take advantage of being able to operate on the data in place. And we are in the early stages of participating in that effort, and we'll be migrating, or in our case, putting copies of certain data into that cloud environment. So we'll stay tuned for more on that. By the time MAIA launches, MAIA may be on that list of things that that may have a copy in Amazon Cloud. So. And then, we also do, on the primary functions here, we also do processing for certain missions. So we do the data processing for MAIA, and we will also be doing it for MAIA. And we have a big outreach and support staff at ASDC that, supports the community. They're there to answer your questions for a variety of different things. And I'll get to a little bit more of that later. Okay, so next slide, Abby, please. And here are some of our distribution sorts of tools and services. This is kind of the primary list here. You can go to NASA Earth Data Search. It's a centralized search client for all of the DACs, where there's a central metadata store, and then there's a client that you can use to search for products that you want based on, it's a faceted search, time, date, parameter, mission. There's a variety of different and combinations of search criteria that you can put in there. And then there's also a what they call NASA Worldview. So for certain data products and certain parameters, we produce tiled imagery that gets sent to what they call the Gibbs system up there at Goddard. And there's a client called Worldview that sits on top of that. That's actually, it's very nice. You can, since it's tiled, you can pan and zoom, use time sliders and things of that nature, depending on the parameter that you're interested in. So we will almost certainly be putting MAIA data, some certain MAIA parameters into the Gibbs system as well in the future. A couple other access points we have, OpenDAP, which is a kind of a web-facing, sort of an API-based thing where you can, if you're savvy enough with the OpenDAP interface, you can do, your own transformations or subsetting or reformatting using that service. You don't have to. We have other ways you can access those services, and you can also access it directly. We have via HTTPS. So that's sort of every piece of data that we have that's publicly available will have a public URL that you can then go and access it. And we provide sample scripts and things. If you're not, if you're more familiar with, scripting and FTP, like a lot of people are, we have some sample scripts to help people get up and running with that, because it's fairly new. FTP is kind of being retired for security reasons. So anybody that wants to directly download data will be through an HTTPS type of mechanism. And we're also provide example scripts for various data sets as well. We're still building our library of those things, but that's as we go forward, you'll see more and more of that. So it's various Python and Jupyter notebooks. I think we have a few R scripts, and then there's also things that come in that get contributed from either our various data providers or other users. So, and down here at the bottom, there is the Earth Data login. So in order to access some of these services, there is a login that they use mostly for metrics purposes. It's not it's not like your bank login or anything, but it's you just have to provide like an email, and they don't ask you for a lot of personally identifying information or anything like that. So it's pretty easy to use. And then we have a forum, which I'll talk about there in a minute. And then we have, just general user support email that you can contact them, our user support directly through that email address. So, next, please. Oh, and we also have ArcGIS portal. So again, this is something that we're moving more and more of our data sets into. You don't necessarily have to be an ArcGIS user for this to be, on the client side, for this to be a benefit to you, because we're again working on making some of our data sets available via these, kind of an image service, these OGC standards, WMS, WCS. If you're familiar with that kind of thing, you can use free and open source clients that can access various data sets, through those API sorts of endpoints. And then that allows you to sort of incorporate that data directly, into various kind of desktop applications and software. So I know that, applied science users do, a lot of them do favor these sorts of GIS clients. So we're providing mechanisms to facilitate that kind of access. And we're also developing story maps that we have here. So you can see this is sort of our front page portal, and I don't know how well it's showing up here, but that second one there from the left, we do have a ArcGIS story map for an intro to MAIA and Tempo, which is very nice. If you guys wanted to go check that out, that's currently available as well. So hopefully that'll give you an idea for some of the stuff that you can do. Next, please. And again, we science outreach and support here. We do have very hardworking science outreach and support staff that are doing these things like working on providing user guides, scripts. We provide data in a variety of formats. I believe MAIA will be provided in that CDF format, but there can be opportunities for conversions depending on what your needs are. And then we have the various GIS tools, the story maps, as I mentioned, and scripts in these various languages. So next, please. And then we have our forum. This is something that's relatively new. It's actually the forum serves the entire, all of the DACs. We host it at ASTC and we manage it, but it does. The idea is that eventually, currently not all DACs are rolled into it at the moment, but that's an ongoing thing. But ASTC, is, and this is kind of nice. It's a place, where you can go and sort of, you can either search for an answer to your question, or you can ask a question directly, in this forum, and then, we have mechanisms for either answering it ourselves, or we have reached back to various subject matter experts that can provide you with additional resources or provide you with an answer to your question. So this is starting to gain a little bit of traction. So I encourage you to check that out as well. I think it'll be a useful resource for you. Next, please, Abby. Oh, sorry, that's just an example of the form that you can fill out. And you can see there's various facets you can fill in to make sure that your question gets funneled to the right person. But all questions do get addressed. So. Next, please. And then finally, we do have a new website that we're working on. It's out there. It's public now. We encourage you to go, take a look at it. And we welcome any of your feedback on, any kinds of, issues, concerns. If you have questions about it, any of the content you find, anything you think's missing that you'd like to see. Again, please. We welcome any and all of that. This is relatively new, so we're still making a few tweaks to it. So feedback is always welcome. All right, next, Abby. I think that was my last slide. So I know that was just a very quick overview of the ASDC, but happy to answer any questions now or at the end. I think I might have gone over my time a little bit.
Yeah, thank you so much, Jeff. We are running a little bit behind, so in the interest of that, if you have a question for Jeff, please type it in the chat. And please also make sure that you're sending your questions to everyone in the chat so that we can all see them. Okay, so I'm going to go ahead and move on to the next talk, which is by Dr. Sagnik Day, who is a professor of the Center for Atmospheric Sciences at the Indian Institute of Technology, Delhi. He's an expert on conducting epidemiological studies using satellite data and is also a collaborator on the MAIA science team and heads planning for MAIA's health studies in India. Now, because of the time change, Dr. Day was not able to join us in person at the moment because it is rather an awkward time in India. So he recorded his presentation ahead of time, and I'm now going to share it with you. So instead of putting questions for Dr. Day in the chat, because he's not here right now, please send them directly to him via email, and I'm going to copy his email address into the chat while the video is playing. With that, I'll start the video.
At Delhi, India. I'll be talking today about particulate health method studies in India and the relevance of MAIA mission. So there is no doubt today that air pollution has become a major risk factor in India. And in fact, the global burden of disease has ranked air pollution as the #2 risk factors. And if you look into the exposure level in India, particularly for PM 2.5, and this is a recent data set that our team has produced for the entire country, you can see that average over the last 20 years, the exposure level in India everywhere almost exceeds the WHO air quality guideline of 10 microgram per meter cube. And mostly in the northern Indian region here, which is known as the Indo-Gangetic Plain, the exposure level is even larger, typically exceeding 80-90 microgram per meter cube. However, the source characterization is very different. For example, this western part is where biomass burning dominates. In the western part, like where the desert is there, dust is dominant. Fossil fuel burning is dominant in the central or southern India, while a combination of fossil fuel and biomass burning contributes to the PM 2.5 development in the eastern part of the country. In terms of health study design, bulk of the studies conducted in India are time series studies looking into all-cause mortality. More recently, based on the satellite-based exposure data sets and the health outcomes from the National Family Health Survey, few studies have come out which looked into, in a cross-sectional setting, looked into like impact on anemia, impact on your stunting. And then now with the availability of the exposure databases, both retrospective and prospective cohorts are being conducted. Some of the major prominent cohorts which are ongoing currently are looking at birth weight, cognitive performance, hypertension, and COPD. So just to summarize is that mostly in India we have so far studied the impact of the acute exposure and not really the chronic exposure, and that's where actually I think India needs to move. So if you look into the meta-analysis here for the time series studies, so here up we have the studies conducted in the Indian cities, and then we have studies conducted elsewhere. So first observation is that the impact of increase in 10 microgram per meter cube PM exposure level to all-cause mortality, the impact is almost similar to what is observed in the developed countries. Now this one factor could be like in India, PM10 is used, well PM 2.5 used in the other cities. Recently when we did the analysis with PM 2.5 in megacity Delhi, which is one of the primary target area for MAIA, we no doubt notice that the impact increases, but still it is in the range of the other cities. In terms of another health outcome, which is birth weight, again, meta-analysis suggests that the exposure to air pollution is usually associated with an 86 gram reduction in birth weight, and a more recent study conducted in southern part of India also estimated similar. So these results point to the fact that perhaps PM 2.5 mass may not be a good metric, especially if you talk about India, because otherwise when in India exposure level is 4 to 10 times higher than the exposure level in developed countries, why are we getting health impacts of almost the similar order? A recent study conducted which also sort of concluded the importance of toxicity. For example, in this study, the lungs of the mice is exposed to the pollution level very similar to China and California. And what has been observed surprisingly is that the inflammatory response is much more severe for the cases of US and not China. And then similarly, another study conducted in Delhi very recently, which also concluded that although the PM 2.5 mass in Delhi is 13 times higher than the mass in Illinois, in terms of toxicity, which is represented in terms of volume normalized oxidative potential, pollution level in Delhi is 5 times severe than the pollution level in Illinois. So clearly you can see that the mass is not equivalent to toxicity. And that raises the question that how representative is the GBD estimates for India, which relies on PM 2.5 mass. And unfortunately, due to the paucity of health data, the GBD estimates cannot be directly validated in India. For example, if you look into the studies conducted in the last decade, a series of studies have estimated premature mortality burden in India. One of the major causes of these differences in the estimates is obviously the way exposure is handled, the way demography is handled. But also one of the major factor is the updates or the changes in the exposure response functions over the years. And if you look again, into the variation in the PM 2.5 compositions across the globe, from the Spartan website, Spartan network rather, yeah. So one can look into that. The lone Spartan site, which is there in Kanpur, it shows very different chemical compositions than most of the other sites across the globe. Now, in Delhi, which is the primary target area for MAIA, PM 2.5, PM1 composition is being measured for the last 1 year by a group from University of Texas, Austin. And what they noticed is that there is a very large variation both in diurnal and spatial seasonal time scale. For example, in Delhi, if you see PM1 varies from more than 200 microgram per meter cube in winter to 50 microgram per meter cube in monsoon. And keep in mind that in monsoon, when the pollution is usually washed out by the rain, still the PM1 level is 50 microgram per meter cube, which is very, very high compared to any standard. But what is also important to notice here is that organics alone in winter exceeds 100 microgram per meter cube. And if you look into that fractions, then what is emerging is that 50% of PM1 is actually the organics in Delhi. And then black carbon fraction is mostly 20% during the monsoon, and then rest are basically all other inorganic species. And similarly, the diurnal variations which is observed for different species, again, it is in response to the source characteristics, how it changes from season to season, and also due to the meteorology. So all this what it point emerges is that the PM 2.5 composition is highly varied in space and time. And as the previous studies are indicating, I think it is very, very important to now understand and move beyond PM 2.5 mass. In a recently concluded summit called Vaibhav, one major recommendation emerged that India must invest in exploring new frontiers like the issue of toxicity and long-term cohort studies to further strengthen India's specific burden estimates. And MAIA actually will now provide us to do this. So with the launch of MAIA, what we are hoping is that we'll estimate the toxicity of the particulate matter, especially in the Delhi National Capital Region, where the pollution level is amongst the highest. And using that information, we can then further derive region-specific exposure response function, and especially moving beyond PM 2.5 mass. And then that will also further help us identifying the baseline exposure level for India. Because when you talk about the general exposure in India, which is quite high, a large fraction of it is actually also the background dust. And whether we, at this point, we really do not know how harmful is the dust. And if dust is not that harmful, so perhaps then we can revisit the national standards and guidelines set. And then finally, with the MAIA data, once it is integrated with the chemical transport model, that will allow us to derive PM 2.5 composition over the entire country and further conduct the studies. So with this, I want to finish my presentation by acknowledging to the various funding agencies for our group. And as I mentioned, please email me for any further questions. Thank you very much.
Okay, I want to thank Dr. Day again for sending in his presentation so that we could all hear it. And as I mentioned, I copied his email address into the chat here so that you can send him any questions that you might have. With that, we're going to move to the next presenter, which is Dr. Meredith Franklin. Dr. Franklin is a professor of clinical preventative medicine at USC Keck School of Medicine and is a longtime user of satellite data for epidemiological applications. For the MAIA project, her interests include California, Kuwait, and Mongolia. And with that, I'll turn it over to Meredith for her presentation.
Great, thank you. Let me put my video on and share my screen. Okay. Can you see the full screen okay?
Yep, looks good.
Okay, awesome. Okay, great. So today I'm going to talk about so yes, I've been using satellite data for quite some time, but I'm going to talk about two specific studies, one in Kuwait and one in Ulaanbaatar, Mongolia, with their application to health and the relationship with MAIA. So first off, just a little bit of background about multi-angle imagers. So MAIA is a multi-angle imager. It also has polarimetry. But basically the nice thing about multi-angle imagers is that they can observe spectral and the angular components of scattered sunlight, which helps us to better characterize aerosols. So we heard a lot about speciation. So the aerosol optical depth is the primary satellite measure of interest, but the multi-angle provides AOD that's distinguishable by size, shape, and absorbance. And this allows us to relate satellite observed AOD and AOD properties to ground level particulate matter mass and its components. So why do we care about composition? Well, we heard a little bit about this from Sanjik, but in general, we see that, PM varies widely in spatial and temporal distribution. It varies in size and shape and its composition. We see different sources. And so the PM type is really diagnostic of the air pollution source. So we see dust, fires. This is a picture of Mongolia, so coal burning. And source attribution really enables targeted control strategies to improve public health and to save costs. So I'm going to talk about MISR, multi-angle imaging spectroradiometer, which is actually, as we've been using it as a test bed for MAIA. So MISR is also multi-angle. like MAIA is going to be. It's on the Terra satellite, so it's been launched. It was launched in late '99, so it's been up for over 20 years. And there's a new 4.4 kilometer resolution MISER product, which we've been using because that's a good spatial resolution for health effect studies. So the nice thing about MISER, it has AOD as well as AOD particle types. And these particles provide fractions to distinguish size. So we've estimated PM2.5 as well as PM10 from these fractions. Particle types and mixtures distinguish size and type, so spherical, non-spherical, absorbing, non-absorbing, and dust. So we've been using these to get at the chemical speciation of PM. And then MISER also has this raw product and additional data to provide observations that are under bright surfaces. So this applies to the Middle East and to Mongolia, where we have bright surfaces due to sand and snow. So the MISER AOD raw has helped us with that. And a lot of these properties that we see in MISER are going to be available in MAIA. So now to the specific studies that we've been conducting. So the one in Kuwait, which is actually a little bit more broadly than Kuwait, but we focused on Kuwait because we have ground level monitoring there, is we're developing this component specific air quality system for the military. So the exposures that the military had post 9/11 deployment in the region, the Southwest Asia region, were really desert dust and sand was a huge component. In some places, the dust storms are occurring up to 50 to 100 times days per year. And then, of course, there's combustion sources. So poorly controlled emissions from motor vehicles, old diesel trucks that are used by the military, unregulated industrial sources, and a lot of the military vehicles and jets that are present on bases. And then finally, burn pits. So burn pits are open waste burning. That was, you can see in this picture here. They open waste burning that was basically the primary means of solid waste management up until about 2012 on military bases. And so they were running continuously on these bases and providing, sort of continuous exposure to very toxic materials, aerosols. So just to show you, Kuwait specifically, we have a few monitoring sites, but we really need satellite data to be able to better characterize the air pollution in the region. So we have been characterizing PM10 and PM2.5 for 3 sites in Kuwait, and 2 of those were sort of historically measured in 2004 to 2006, and 2 of those sites were restarted in 2017, and we've been monitoring the data PM10 and PM2.5 as well as PM speciation at these sites. And we could see that this is a region of high air pollution, the concentrations of PM10 up to 92 to 100 micrograms per meter cubed, and the average PM2.5 is well above the standard that we have here in the US. So we've been estimating PM2.5 from AOD. We've been using a lot of machine learning methods. So we take the AOD. In this particular study, we were also using visibility and some meteorological variables and applying machine learning to then generate these nice maps of, well, this is showing the AOD, and then we get the predicted PM2.5. And this is Kuwait and Iraq here. So we are using these estimates for our military exposures. And then specific to MISER, we've been using the MISER mixtures and the MISER components, like I mentioned, the AOD components, to estimate sulfate, nitrates, carbons, and dust. So this allows us to use, again, we've been using machine learning because there's a lot of these AOD products. So we have these highly correlated mixtures and products that we have to use machine learning for to sort of learn these different PM species from these AOD types that MISER provides. And we've been getting good reliability on that. And we can just see here the variable importance where we have different types of AOD that are important variables in predicting things. I didn't put these up here, but this is sulfate, nitrate, elemental carbon, and dust. So we see these different mixtures that really predict dust very well. So the epidemiological application here is that for this particular study, we're looking at, we've recruited, well, I have not, but a medical doctor at the VA has this recruitment process where they're looking at lung function of the veterans that were exposed during post 9/11 Gulf War era service in the region. And there's a pool of over nearly 1.5 million veterans that are available. So they've been recruiting thousands of these veterans. And what we've done is with this source differentiated air quality estimates that we've gotten, where we've provided this tool in which we can assess their exposures based on the speciated PM that we've been getting from MAIA. Okay, so now on to Mongolia. So we've done something similar in Mongolia and been doing a more traditional EPI study from that. So the primary source of air pollution in Mongolia comes from burning coal and biomass for heating and cooking in the Gur area. So you can see here that there's a huge population in the sort of edge of the mountains, the foothills of Ulaanbaatar, Mongolia, where they live in these Gur settlements, and they're really producing a lot of pollution from burning coal. And these are the few monitoring sites that are available in the region, just to show you where the Mongolia, the capital, is. And these are some of the observed concentrations. So you can see that the concentrations are going way up in the wintertime, up to over 600 microgram per meter cube. So in this case, we've been using we did use the MAIA mixtures again to distinguish the dominant particle matter types. We used the 74 mixtures that showed there was a greater proportion of variability in the winter that were explained by small particles. So we were able to attribute these to sulfates from coal burning. And then in the summer, we found a greater proportion of variability from dust, non-spherical dust particles, indicating that there was a contribution from Gobi Desert dust in the summer. So we basically were able to use these and we did this, again, machine learning with all of these mixtures in order to estimate both different components. So we estimated PM 2.5 mass. This is just the picture of the mass in the summer and the winter here on the left in the summer. And we were able to distinguish sulfates and dust from these mixtures as well. So these components are now being used in a study where we're looking at birth outcomes. So we've gathered records from paper birth records, actually, from the maternity hospitals in Ulaanbaatar, and we've linked up these estimates of PM and PM sources from the machine learning models that we've applied to MAIA, and are looking at both stillbirth outcomes and congenital anomalies. Okay, so in summary, basically with multi-angle imaging, we have aerosol properties that enable the distinction of size, shape, and absorption. We can use these properties to relate to different surface particulate matter components such as dust, sulfates, nitrates, and elemental and organic carbon. And MAIA is going to be, I showed a lot of work with MAIA, but MAIA is going to be providing very similar aerosol properties, enhanced again at a 1 kilometer resolution. And the nice thing about MAIA is also going to couple it with ground level monitoring over primary and secondary target areas that Abby showed. One of those areas includes Kuwait. And so this is really a great opportunity to see that there's support of global studies of the component-specific air quality, and then these health and epidemiological applications. And it's really shown here that we can do this in understudied areas where the pollution is really high. So these are just some acknowledgements, and thank you. If you have any questions, please let me know.
Great. Thanks so much, Meredith.
Thanks.
So a few words about the remainder of the webinar. This webinar does go until 10:30, but of course, a few people may need to drop off right now for other meetings. This meeting is being recorded, and the recording will be posted on ISEE's YouTube channel. So if you have to drop off, you can watch the end later. So what's going to happen right now is I'm going to share just a couple of slides about MAIA's data products, now that we've heard a little bit about how you might want to use them. And then at that point, we'll open it up for questions, and you can direct questions to any of the speakers. So let me go ahead and share my screen. Okay. And once again, just a quick check. Can you see my presentation?
Yes.
Okay, perfect. Thank you. Okay, so let me just go through real quickly what MAIA's data products are going to be. So when we get the data down from the instrument, it's in the form of raw ones and zeros, and we call that the level 0 data. It's not a public data product because it's not much use to anyone in this form. So the first public data product that we produce is called our level 1 data. And this is basically, you can think of it as what the instrument is actually seeing. As Dave mentioned earlier in the webinar, the heart of the MAIA instrument is a very sophisticated camera. So what the instrument sees is pretty much a picture, but since the MAIA instrument has 14 spectral bands and also collects polarimetric information, it's possible to make a wide variety of different pictures using that information. And that will be plotted at 250 meters per pixel and include georegistration information. And then Meredith did a great job of covering in her presentation what you can do with a satellite aerosol product like the one from MAIA's predecessor, MISER. So MAIA will also be producing an aerosol data product. We call it our level 2 aerosol product. And as Meredith mentioned, it will be at 1 kilometer spatial resolution, and it will include aerosol optical depth and many other aerosol properties that can be used similarly to how Meredith was using MISER data. But of course, you're probably, if you're here, most interested in MAIA's PM products. So let's talk about those. There are actually 2 of them. So first, we'll talk about the level 2 PM product. So the level 2 PM product is only produced on days in which MAIA overflies a particular target area. So for the primary target areas, that's 3 to 4 times per week, but it's not always going to be on the same days of the week. It will also be produced at 1 kilometer spatial resolution, but as you can see from this kind of mock-up that I'm showing you here, the level 2 PM product only has results where the level 2 aerosol product has results because we use the aerosol product to make the PM product. So that means that there may be holes in the product due to cloud cover, shallow water, complex terrain, a number of factors. So since we know that having a product that only occurs on certain days of the week and has holes in it may not be the most useful for epidemiological applications, we're also making a second PM product called the level 4 PM product. And we'll be using our bias-corrected chemical transport modeling to basically produce this product every day of the week, whether MAIA has overflown the target or not on that particular day. But of course, please note that the data quality will be higher on the days when we have MAIA data to use. It will also be gap filled, so you won't see any of those holes due to clouds or other factors. Both of the PM products will have the concentrations of the PM components that are listed here. So total PM10, total PM2.5, and then PM2.5 broken down into sulfate, nitrate, organic carbon, elemental carbon, and dust. Okay, so those are, at high level, the MAIA data products. So just a quick note about MAIA's satellite orbit. You may not be particularly interested in orbital mechanics, which is totally fine. But MAIA's host spacecraft will be launched into a sun-synchronous polar orbit. And the reason why you need to know that is because that every time that MAIA overflies a target, it'll be roughly the same time of day, usually mid-morning for most of our targets. And because of this orbital configuration, as I mentioned, MAIA won't be able to observe every target every day. We're aiming to observe the primary target areas 3 to 4 times per week, and the secondary target areas may be a little bit less than that, somewhere under 3 times per week. So I also want to mention something called the MAIA simulated data. So the software that creates the MAIA products is currently being wrapped up. And once it is, we'll be doing what's called end-to-end software testing. And what that means is that we'll be producing data products. Obviously, they won't have real MAIA data in them because MAIA hasn't launched yet, but they will include modeling results and use surface monitor data to create products that in format will be identical to what the MAIA products will look like, and they will have results in them. And what we want to do is we want to publish that data so that you as early adopters can get access to the data products. You can try them out, see how they work, figure out how you might want to incorporate them into your future work, and also give us feedback about what's working and what's not in the simulated data products. So next year, we'll have simulated data, and that will be available through request on the MAIA website. In case you're wondering, why does it have to be by request? It's just because we want everyone who uses the simulated data to understand that it shouldn't be used to make decisions or come to epidemiological conclusions, because it doesn't have real MAIA data in it. So that's why we're doing it by request. And then after MAIA launches, we'll go through a period called checkout, where we do all the testing to make sure the instrument is working as expected. And then once checkout finishes, we'll start producing the real MAIA data products. And as Jeff mentioned earlier, those will be available through the Atmospheric Science Data Center, as well as through some of the other resources he mentioned, like Earth Data Search. I'm not going to get into too much detail on this slide. I know there's a lot of text on here. If you have any questions about it, please do ask. But I just want to let you know that because of the geostatistical regression modeling approach that MAIA is using, we do need to reprocess our data periodically in order to include the MAIA observations and the surface monitor data that have accumulated since the last time we did reprocessing. So the long and short of this is that the longer that you wait to use MAIA data, the higher quality that data will be. And in fact, the highest quality data will be produced after the MAIA mission has ended, in fact. So once we've gone through mission closeout, which is when we turn off the instrument, we will do a final reprocessing and produce models that have all of the data that MAIA has ever collected and all of the corresponding surface monitor data. And that final reprocessing will produce the data that has the highest quality. But of course we understand that for certain use cases, you can't wait years in order to have access to the data products. So we will be producing data as we go. Just keep in mind that the data quality increases the longer that you wait. So for the next 2 years until launch, which is supposed to be in 2022, we'll be producing and then updating the simulated data products. We'll be holding more early adopters events. So this is a webinar. It's just kind of a give information kind of event, but we also hold in-depth workshops, which last for longer and give the opportunity to engage in interaction and vet the test data products, give feedback, etc. And of course, we'll also begin developing the user guides, tutorials, and short courses that will be available to help you use the real MAIA data products once they're available after launch. So in order to hear about these resources, I highly encourage you to join the early adopters mailing list so that you will be notified of early adopters workshops and also resources that become available. So here again is the link to the applications page of the MAIA website. On that page, you can join the mailing list by downloading the contact form and sending it to me. It has more information about the data products, and later, once the simulated data becomes available, the application to receive that data will be on this page of the MAIA website. Okay, so that's all I have. I'm going to continue to share the screen while we do questions so that if you want to get in touch with any of us who presented today, you can copy down the email address of the person that you want to get in touch with while we're answering questions here. But with that, what I want to do is open the floor for questions. So let me get the chat window popped up if you prefer to ask your question in that form. Otherwise, please feel free to unmute yourself and ask questions. We have a relatively small group here today, so we can definitely do that. Questions, please. If nobody asks questions, I'm going to start asking the panelists questions. Okay, well, here's my question to get things started off with. So this is for Dave and Jeff and Meredith. Any of you, if you would like to take this question, or all of you. My question to you is, what do you think would be the perfect future of satellite data for air quality applications? We have MAIA coming up, but what do you see as the ideal future beyond MAIA?
I'll start it off, Abby, and then Meredith and Jeff or others can weigh in. So one of the limitations of MAIA is that we're only looking at a discrete set of targets around the world. We have a dozen primary target areas. We have a couple of dozen secondary target areas. And this is driven by several factors: the way the instrument works, being a single camera that's pointed, limitations on downlink data rates, budgetary resources, and things like that. I think, once we have the ability to demonstrate that this kind of observation can provide useful information for epidemiological studies, I think that there would be interest in expanding the coverage that can be obtained. And this would be require then a different instrument design. The deployment of surface monitors is, that's a very time consuming and expensive proposition. So that component also could stand some development in how to do that more cost effectively. So I think greater coverage and ease of processing the data in the future would be things that that I would be interested in seeing in the post-MAIA era.
I completely agree. I guess, yeah, we rely a lot on the ground level monitoring, which is expensive and, limits where we can look. If there's any way that, MAIA can provide enough information that we can, not rely so much on the ground level data, and we can actually just use satellite information to estimate ground level PM 2.5 without so much training and without so much reliance on the ground level data, that would be ideal.
Great. Thanks, David and Meredith.
I guess from my point of view, it's just, one of the challenges that we have, I mean, the different instruments and the different measuring, techniques, they all have their sort of focus and strength. And I think the challenge for us to be able to serve the air quality community writ large is to be able to find some way to not just house all that data in one place, but to, how do you leverage the certain synergies between, various things so that somebody, can come in and answer their particular question and get the data that they need, co-located in time and space, over their particular area in order to answer what they need. So it's a technical challenge, but it's also a science challenge as well. So.
Great, thank you. So we did have a question come in while we were discussing this. So Nargis asks, I hope I'm getting your name right, Nargis. Do we have to pay for access to receive MAIA data? And the answer to that is no, you do not have to pay. NASA data is in 99 cases out of 100 provided free of charge. So you will be able to access it completely free through the Atmospheric Science Data Center. So hopefully that answers your question. And follow-up question, is your data only about PM 2.5 or do you have information about PM 10 and ... as well? So let me, real quick, I'm going to flip back through here. So bear with me here. So great question. So this is what, these are the PM components that will be included in MAIA's PM products. So we do have total PM10 here. It's not going to be broken out into species like the PM 2.5 data will be. But we do have total PM10. So hopefully that addresses one of your questions. I'm guessing what you might have been thinking of when you wrote ... was maybe something like PM1. So PM1 is certainly something that has been, asked about for MAIA several times, and understandably so, given that current research is starting to really show that perhaps PM1 is an even more powerful metric to track versus PM 2.5 in order to understand health effects. So the answer about PM1 is that the MAIA project officially has no plans to produce PM1 data. When we proposed the project to NASA, which was before 2016, PM1 was, not very well studied at that point. So it wasn't included in our official proposal to NASA. And of course, when NASA provides money to a mission, they say, well, you need to fulfill the requirements that you set out in your proposal. So, these are the things that we put in our proposal, and these are the things that we need to focus on providing at high quality. But we do hope that, you as early adopters definitely have the ability to take, MAIA's existing PM products, or maybe even to go back to MAIA's aerosol product and use that to produce your own PM products. And when you do that, you have the freedom to produce them in whatever way you think will provide the information that's most helpful to you. And if that includes, extrapolating PM1, then we certainly hope that some of the early adopters may be interested in using MAIA's data to investigate PM1. And a second follow-up question, thank you, Narjust, for all these questions. Do you not have data on gas pollutants? No, we do not. And I think that's a great lead-in to a question that I was thinking of posing to Jeff and to any of the other panelists who are interested in discussing it. So MAIA will be launched in the same year as another NASA project called TEMPO. In fact, I heard at the beginning that at least one person on the call was at the TEMPO Early Adopters Workshop yesterday. So MAIA and TEMPO are kind of complementary air quality projects in that MAIA will be studying particulate matter and TEMPO will be studying gas pollutants. So there are some important differences between the two projects in terms of what areas will be covered. So as you saw, MAIA will have discrete targets, and they will be, kind of the size that you see here. This is California that's being depicted in this example. But the target areas will be several hundred kilometers in size. But TEMPO is actually going to be in geostationary orbit, which means that it will be always staring at North America. So for MAIA, you get data for discrete target areas around the globe. For TEMPO, you get high temporal resolution data, but only for North America. Of course, TEMPO does have some sister projects of its own, GEMS over Asia, and there's a Sentinel mission that will be over Europe coming up that will have very similar instruments. So the three of them together will cover a good portion of the globe. So I guess, as a follow-up question to that, I will pose the question to Jeff. So Jeff, Atmospheric Science Data Center is going to be the data center of record for both MAIA and TEMPO. So do you have any plans for any special synergy between MAIA and TEMPO, or what are your thoughts in that regard?
Well, we don't at the moment, but I mean, we recognized for a while that the potential for this kind of synergy is really high. But we want to get some, we need to hear from the community about, the sorts of types of things that they would like to see, or how they might envision, using data from MAIA and TEMPO together. We've had a few of those conversations, and even at the TEMPO science team meeting, Abby, I think you were sitting in on it. I think a lot of people recognize it's like, oh yeah, there's really a lot of potential here, but nobody, I think, has had the time to quite think it all the way through yet. So unfortunately, we don't have a specific plan as of yet, but it's top of mind for us. So we're hoping that, by the time these two launch, or maybe not too long after they, too long after they launch, we might be able to, deploy some kind of synergistic services, but it's just not 100% clear what those would look like right at this moment.
Thanks, Jeff. Well, it is certainly true that MAIA and TEMPO data will both be available from the Atmospheric Science Data Center. So if you're grabbing MAIA data from ASDC, you can grab TEMPO data at the same time. Okay, let me go back to the slide with the email addresses. So do we have any other questions? We can be here for about 10 more minutes. And these questions don't have to be limited to epidemiology or to the materials that were covered today. If you have any questions about MAIA in any way, shape, or form, please feel free to ask them right now. This is your time. So Nathan asked a question, late to join today, will you be posting the slides after the session? I wasn't intending to post the slides exactly. However, this entire meeting is being recorded and it will be posted on ISEE's YouTube channel. So you will have the opportunity to go back and listen to all of it. I will probably look to repost ISEE's YouTube link on our own website, and I'll also be sending it out through the MAIA Early Adopters mailing list. So does that answer your need, Nathan? Okay, perfect. Okay, and then Ian asks, could you give a brief overview about how the gap filling in the level 4 PM product works? So Dave, do you want to take that question?
Sure. So are the geostatistical regression models that Abby described, they're actually going to be two kinds. There's going to be ones that relate the satellite-derived aerosol information to surface PM. These use a data model that involves training the coefficients of the model between the various predictors, which include the aerosol information from the satellite, along with land use information, meteorological information, et cetera, to predict PM concentrations. And those models are trained. And then once we use the satellite and surface monitor matchups to train them, then we can apply it to the rest of the satellite information. There's going to be another set of geostatistical regression models that relate estimated PM concentrations out of a chemical transport model to surface PM. Now, model-based PM and speciated PM are notoriously biased, but we will use the GRMs to correct those biases by training corrections to the chemical transport model outputs, again, using the same, the data from the surface monitors. So the result is that we'll have maps of PM using the satellite information that'll have holes in it because of cloud cover, or due to the fact that on a certain day, because our products are daily average, there will be certain days where the satellite didn't overfly a particular region. That's where we'll use the estimates of PM that come out of the bias corrected chemical transport models. Now, there will be some places where we have both results. We have both the satellite derived PM estimate as well as the one from the chemical transport model. There will be, as part of the algorithm, generation of uncertainty estimates that go with each of those. And there will be a weighted averaging of the results from the satellite and the chemical transport model. And that weighting will be inversely proportional to the uncertainties associated with each. And that's the way this ensemble averaging approach will be used to generate the gap-filled product.
Great. Thanks so much, Dave, for that explanation. Ian, does that answer your question adequately? Do you have any follow-ons? Okay, perfect. And yeah, Dave, your answer made me realize that there was something that I forgot to emphasize about the MAIA PM products, which is that they are both the level 2 and the level 4 are daily average products, which means that even though MAIA will be overpassing the target, as I said, usually mid-morning time, both products will present a 24-hour daily average. So we have a question from Kathy. Will MAIA provide any satellite data for non-target areas? So the answer to that is no, unfortunately. Just the design of the MAIA instrument. So, the camera that makes up the heart of the instrument is mounted on a gimbal, which swings back and forth. And that's what provides MAIA's multi-angular capability. So because of that design, what that means is that in order to capture data of a particular target, we actually have to do a rather complicated maneuver as we're passing overhead, where we gather data from one angle and then we swing the gimbal to get another angle, and we keep doing that multiple times. So that's the whole reason why MAIA is a targeted instrument, is because of the gimbal maneuvers that we have to do as we're passing over the target. And that's also the reason why that MAIA will only be collecting data over the target areas and not for any other regions, unfortunately. of course, we wish we could have an entire armada of MAIAs that would cover the entire globe, but unfortunately don't quite have the budget for that.
I'd like to ask Kathy, is there a particular place that you're interested in that's not on our current list?
German data.
Yeah, so Germany's going to be problematic. We have 3 European targets right now. We have 2 primary target areas, one in Barcelona, one in Rome, and then a secondary target area in Belgrade. Because of what Abby just described, in the way the camera has to point at the different angles, by the time that we're finished taking data over, say, Rome, and we have a backward looking view angle, the satellite has flown where it's well to the north of Europe when it's acquiring that view. So that means that we don't have the possibility then of collecting German data as a result of that. It's useful for us to know where people are interested, though. Abby mentioned, we have a primary mission duration of 3 years. There's the potential of an extended mission. It's useful to know what people are interested in, because during the extended mission, there might be the possibilities of some adjustments to how things are collected to meet needs.
Yeah, perfect. Thanks a lot, Dave. And thank you, Kathy, for asking that question. Okay, so we just have, 2 minutes left here. I'll once again go back to the slide that has all of our email addresses. If you have one last question, please do ask it right now. Otherwise, I would say, thank you all for being here. And we certainly hope that you would be interested in joining the MAIA Early Adopters Program. And again, if you're interested in joining, please do here's my email address. Please just send me a quick email and I will send you back the very easy join the email list form. It just has a couple of questions that help me understand what your potential interest is in MAIA. With that, any final questions?
Well, thank you all very much for attending, and thank you to Abby and all the presenters for such a really interesting webinar today. I was very interested in it, so thank you very much for organizing and presenting. And this will be exciting when we start getting the data. Great, thank you so much. I'll stop the recording now.